All right, so let's do another one. Since we did tangent in this one, let's look at cosecant for the next one. So I'm going to open a new sheet of paper and we'll work through this one. So we've got y equals -2 cosecant of pi x. We're going to start with that parent function, and that's cosecant of x. And we'll go back to that chart with those nice values in it. That's something you may want to write on a cheat sheet or keep handy when you're working through these. So this is going to go on my parent chart. This is one cycle of the cosecant function. I'm going to draw a dotted line. This is where my vertical asymptotes are. So I'm at -2, -1, -2, and then 2, 1, 2. So we do left, right first. There's no left, right. Then we do stretches and shrinks. So I'm going to start by multiplying by the 2. Oops. So if you think about what that does, that's going to horizontally stretch. We're going to multiply the y's by 2. Vertical asymptotes are still going to be vertical asymptotes. The x's were not affected here. Okay, now we also have another one of these going on, and that's being caused by the pi, which is affecting the x's. So let's think about what it's doing here. We're going to end up multiplying the x's by the reciprocal of pi, which is 1 over pi. So 1 divided by 3.14. This is going to be a horizontal compression. Okay, this is going to affect the axis horizontal. Let me go back over here. This is actually a vertical stretch. I'm sorry, I misspoke earlier because that stretched on the y values. If it affects y, it's vertical. If it affects x, it's horizontal. So we have a horizontal compression going on. So we're going to multiply each of these x values by that y value. By that 1 over pi. So when we multiply that, negative 5 pi over 6 times 1 over pi is negative 5 over 6. Then we're going to have negative 1 over 2, 1 over 6, negative 1 over 6, and then 1 over 6, 1 over 2, 5 over 6. Y stay the same. Now we have to apply this to those vertical asymptotes also. So we're going to have a negative 1, 0, and 1 there for our new asymptotes. And then now we just have to deal with the reflection there. And that's going to reflect over the x-axis, which changes the sign of y. So I'm going to flip all those signs. So there's our table for that. So let's see if we can graph these. All right, so I'm going to start with that parent function here. So at negative, let's start with the asymptotes. We have an asymptote here. We have one along the y-axis here, and then we have one here. So negative 5 pi over 6, negative 2, negative pi over 2, negative 1, pi over 6, negative 2. So there's that u. And then pi over 6, 2, pi over 2, 1, 5 pi over 6, 2. And then we have this kind of thing there. All right, so with this one, if I want to put them on the same Cartesian plane, the original function was everything in terms of pi, right? So we graph that in terms of pi. This one doesn't have any pi's with it. So to me, it seems like the easiest way to do that would be to take these numbers that we created and let's turn them into decimals. That way we know where this stuff is going to live on this graph. All right, so I'm going to go along that bottom and I'm going to turn everything into decimals. So pi divided by 6 as a decimal, and I'm going to use a different color so we can actually see that better. 5 pi over 6 as a decimal is about 0.52. Pi over 2 as a decimal is 1.57. And I don't think we're going to need to go any further than that. Um, so this guy would be at 2 pi over 6, which would be 1.04. Same thing here. This would be at negative 0.52. This would be negative 1.04. And this would be 1.57 negative. So we've got those decimal representations. So what is 5 over 6? 5 over 6 is 0.8. And that's 1/2. 1 over 6 is 0.17. So this would be negative 0.17, negative 1/2, and negative 0.83. So we got to figure out where these points are going to be. Let me see if green will show up. So negative 0.834. Negative 0.834 would be up here. Negative 1/2, 2, and then negative 1/6, 4. And then we have 1/6, negative 4, 1/2, negative 2, and 0.83, negative 4. somewhere around here. Asymptotes, I really probably should have done those first. And then again, 0 is an asymptote for that transformation. So here's my graph. So you can see major changes, right, between those two graphs. My blue one was the original. That green one really shrunk in, and that's because we multiplied those x's by a factor of 1 over pi. And then we see that stretch happening, right, because of that factor of 2, when we multiplied each of those y values by 2. And then you can see that the blue started upside down and then went right side up, but that reflection flipped everything. So that green one starts right side up, and then the other part of it goes upside down. So major changes happening with that one. So, but the process is the same for all of them. Find your nice set of points, do left, right, stretch, shrinks, reflections, and then move it up or down. This one did not have an up and down movement, but if it did, we could always put that in.